Hello again. I'm just continuing on with the rest of the lecture. This is going to be number 4, chapter 9. So talking about p-value. P-value is the probability of making type 1 error. I'm sorry, the alpha. Alpha is the probability of making type 1 error. If the p-value that we calculate is less than or equal to that, then we go ahead and reject the H0. There is another method called critical value or z-value approach, or critical value approach. If you guys go to slide number 16 and slide number 17, they are showing you examples like these that I have drawn in here for you guys. If the p-value is in this area, then we reject. If the p-value is in that area, then we reject the H0. This is the rejection rule. You know what, let me write down the rejection rule for you guys. Reject H0 if p-value is less than or equal to alpha, if z that we calculate, this is for critical value approach, is greater than or equal to z of the given alpha. For negative side, z calc less than or equal to negative z of the alpha, and the same thing for t, and the same thing for z sub alpha over 2. Okay? So all you have to do is just z sub alpha over 2, z sub alpha over 2 for each side. So these are the rejection rules. If you find the p-value by using the z, by using the test statistic or the z formula, and then you compare it with the value of the alpha. Value of the alpha should be always given to you. Sometimes they tell you for 85% confidence level, that means your alpha is equal to 0.15, excuse me. Or for 95% confidence level, that means your alpha is equal to 0.05. On slide number 18, they have these rules listed. And then they, on slide number 19, they have the critical value approach. In critical value approach, they will go and calculate the z, and they compare that against the z of the given alpha. All right? For example, let's see that we find the z in here, which is 1.8. If we're dealing with the 95%, for 95%, if it is one tail, okay, then the z of the alpha, let's do it over here because this is the upper tail. If, wait a minute, this one is the upper tail. Okay? Now, for, let's say that z is z calc, let's say z that we calculate is equal to 1.9, for example. If we're talking about 95%, z of the given alpha is going to be, z of the alpha is going to be 1.96. So look, the z we calculated is 1.9, this is 1.96. We reject if our z calc is greater than z of the given alpha. That means in this case we don't reject, we accept the H0. We accept the null hypotheses. All right? Again, slides number 18 and 19, and also 20, they are explaining, wait a minute, 1.96 to z for 95%. For 95%, this is 1.645. Okay, 95%. And then for 90%, it is going to be 1.9. When we get there, I'm going to go ahead and explain this. Now, if you say that, wait a minute, back in chapter 8, those of you remember, for 95% we had 1.96, that's a mistake that I made, so apparently you might make a mistake, the same mistake. Why this is 1.645 and it is not 1.96? This is the reason. If you have that question back in chapter 8, we said for 95% confidence level, we said that the z sub alpha over 2 was equal to 1.96. But in here, we don't have alpha over 2. Okay? If we have 95%, that means alpha is equal to 0.05. Half of the alpha, that's 0.025. 0.025 plus this, that becomes 0.975. We go to the z table, we locate 0.975, then the value of 0.975 is 1.96. But in this case, we only have z sub alpha over 2. If we had equal, not equal, then yes, we have half of the alpha. These are both one side, like upper tail, lower tail. And when it is 95, if you go to the table, you cannot find 0.95. And you find 0.9495 and 0.9505. And we take the average of the two, then the value for z is 1.645. Anyways, if the z that you have calculated is greater than, if z that you have calculated for positive side, z that you have calculated is greater than or equal to z of the alpha, then you go ahead and reject the null hypothesis, the H0. On slide number 21, there are some steps for calculating the p-value and z. And in order to calculate the p-value, you always must calculate z first in order to find the p-value. Okay? If this is the case, I always suggest that students go ahead and calculate the z-value, and once you have the z-value, then just go ahead and use critical value approach and compare that against the z of the alpha, and that way you can decide whether to accept or reject the H0. On slide number 21, they have those steps: develop the null and alternative hypotheses. Every time that you're going to solve a hypothesis testing problem, first thing you have to do, you have to develop the hypotheses. That means you have to show if it is this case, if it is this case, or if it is equal and not equal. So H0 is equal, it states that mu is greater than or equal to mu sub 0, and so on and so forth. First, you have to do this. Step number 2, specify the level of significance. Level of significance means alpha. So you have to specify what your alpha is. Let's say 0.05. Step number 3, collect the sample data and compute the test statistic. So step number 3, z is equal to x minus mu divided by sigma over square root of n. All right? Now that you found your z, you can go and find either use the z that you calculated, compare this against the z of the given alpha, or go ahead and find the p-value and compare it against the alpha. These are all on slide number 21 and 22. Now, I'm going to go through this example. The Metro EMS example, slide number 23. The response time for a random sample of 40 medical emergencies were tabulated. The sample mean, that is your X bar, is 13.25 minutes. The population standard deviation is believed to be 3.2 minutes. The EMS director wants to perform a hypothesis test with a 0.05, this is your level of significance, your alpha. Level of significance to determine whether the service goal of 12 minutes or less is being achieved. This X bar or mu for the if you're dealing with the sample. In here we're dealing with the population, so this is supposed to be the mu. In here, X bar minus the mu. My mistake, so I fixed my mistake. Now if we go to, let's see, step number 1, develop the hypotheses. Develop the hypotheses. The hypotheses, they want to reach the goal mu less than or equal to 12. A mu is greater than 12. This is step number 1. Step number 2, specify the level of significance. Alpha is equal to 0.05. Yeah. Now, z of the alpha is equal to 1.645. If you want to know why 1.645, one, two, three. Alpha is equal to 0.05. Okay, this is one tail upper tail. That means the alpha is on this side. One tail upper tail. Let's say that right here is 0.05. This is 0.05, and then this right here is 0.95. You go to the Z table, locate 0.95. We can't locate 0.95. We have the closest two numbers to 0.95. One is 0.9495, the other one is 0.9505. So we take the average of the two, then the Z value, Z of the alpha comes out to be 1.645. Okay? So this is how we find Z 1.645. Now we go ahead and step number 3. This is a step number 1, a step number 2, a step number 3. Calculate the test statistic divided by sigma over square root of n. I think n was what, 40? Somewhere here. So X bar, they said 13.2 minus mu, which is 12, divided by sigma, which is 3.2, divided by square root of 40. So this comes out to be 2.47. Okay, right now we can stop right here. This is our Z that we calculated. So this is the Z calc, which is equal to 2.47. Z of the alpha is 1.645. Because our Z is greater than that, we have to reject. They're not going to be able to reach that goal, making it 12 minutes or less. Now let's go further ahead and start doing the p-value. We go to the Z table and we find the area where they are going to meet their goal. That means according to 13.2 minutes. So I'm gonna see if I can, yeah, this is for 2.47. 2.47 is going to be 0.9932. It's right here. It's right there. 0.9932. That's the area for 2.47, because this is upper tail. Those of you remember the upper tail, this is the upper tail. If this is the upper tail, then 1 minus that value, which is 0.9932. So 1 minus 0.9932, that is equal to 0.0068. This is our p-value. So p-value is equal to 0.0068. Compare this with the alpha, which is 0.05. This is less than this. Therefore, we have to go ahead and reject the H0. They cannot achieve their goal. This is on a slide number 24, 23, 24, and 25. 23, 24, and 25. Now, even if you want to use the critical value approach, again, 1.645, that's Z of the alpha. The Z we calculated is 2.47 is greater than that, therefore we have to reject the H0. On slides number 26 and 27, they are, no, just number 26, they're showing you this on the graph. If I want to show that to you, well, they have it on slide number 26. All right, with the Z value and the P value and the alpha. Okay, and on slide number 27, they have the Z value approach, the critical value approach. On slide number 28, they're talking about the two-tailed hypothesis testing with the p-value approach. Okay, let me explain to you what they mean by this. For two-tailed, when we have H0, mu is equal to mu sub 0, HA, mu is not equal to mu sub 0. This is the two-tailed hypothesis testing. In two-tailed hypothesis testing, we have to measure the area of the P, or whatever p-value that we measure, that belongs to only one side. So if this is the area of the rejection, which is alpha, that's going to be half of the alpha. And in here is also half of the alpha, right? Let's say that they give us alpha equal to 0.05. half of the alpha is equal to 0.025. When you calculate your p-value, in this case, let's say that your p-value is 0.01, for example. If you want to measure, to compare your p-value in two-tailed hypothesis testing, if you want to compare your p-value against the total value of the alpha, in this case, which is 0.05, then you must multiply that by 2, because this is always only for one side. Multiply by 2, that will be 0.02. So you compare 0.02 against 0.05. Or, if you don't want to multiply this by 2, then you do this p-value against half of the alpha. And that way, you will decide whether to accept or reject just by half of the alpha against the p-value. But if you want to use it against the total value of the alpha, then you have to multiply that p-value by 2. And the same rule applies, the rejection rule for z-value and for p-value. They both are still the same for the two-tailed hypothesis testing and one-tailed hypothesis testing. There is an example in here on slide number 30. So I want you guys to read the example. The sample size is 30. The mean weight is 6 ounces. And they want to know if there is going to be any underfilling or overfilling of the tubes. And then the standard deviation is 0.2. So I want you guys to please read this example. And then the level of significance is 0.03. Okay? The first thing we have to do is we have to develop the hypotheses. So they say that the mean weight of the toothpaste is 6 ounces. Equal to 6, not equal to 6. Okay? This is step number 1. Step number 2, specify the level of significance. Alpha is equal to 0.03. Alpha over 2 is equal to 0.015. Right? Half of the alpha. Step number 3, go ahead and calculate test statistics. Z is equal to, so my markers are not cooperating. Hold on, guys. Z is equal to x bar minus mu divided by sigma over square root of n. So x bar is 6.1 minus 6 divided by sigma is 0.2 divided by square root of 30, which is the sample. So z comes out to be equal to 2.74. 2.74. Okay? Go to slide number 33, the p-value approach. In here, they have calculated a p-value. If you go to the z table, the area for this is 0.9969. So 1 minus this is going to give us the p-value, but you have to multiply that by 2. Okay? So 2 times 1 minus the p, this is the area. Okay? That is going to be 0.0062. So 0.0062 against the level of significance, which is 0.03. So this is smaller than this, therefore we go ahead and reject the H0. Okay? Or if you want to go by Z value, we have to go ahead and find out what the Z of the alpha would be for 0.03 on one side. Then we have to calculate the half of it. You know what? I'm going to stop right here. I'm getting very close to 25 minutes and 30 seconds right now. I'm going to leave this on my board, and I'm going to spend more time on this in the next video. I'll see you guys later.